Yeah, but without further ado, I guess we need to get started. Thank you so much, Dan, for taking the time to come and do this talk with us. Maybe you can just start with like a quick introduction of yourself.
Yeah, that sounds great. And yeah, thank you for inviting me and thank you everyone for being here. So hi, I'm Dan. I'm a co-founder and CTO at Goodfire. At Goodfire, we're a mechanistic interpretability research company. I'm going to talk about all of the exciting stuff that we're doing. Um, but fun fact is that I went through the Blue Dot technical alignment program a few years ago. So I'm excited to come back and speak with all of you now, and share what I've learned along the way. But yeah, it's a great community and it's great to be here chatting with all of you today.
Yeah, and a fun thing I think you told me last time was that Neil Nando was like one of your facilitators back then.
Yeah, yeah, that's right. And he also uh he came to speak to us and he also said that it was a bad idea to start an interpretability company during that chat. So yeah, it's fun to be back now on the other side of that.
And maybe as well, like it would be useful, be interesting for other people to know, like how did this like idea for this company come to start, the origin story of Goodfire.
Yeah, yeah. So I've been building startups for over a decade. And uh around the launch of ChatGPT, GPT 3.5, I sort of very quickly realized the direction that things were going. I've always been a very impact motivated person, always trying to work on whatever I thought were the most important problems in the world. And it just became clear to me that if I wanted to have a really, really big impact, the way to do that was to do something in AI and specifically something that can make a really big impact in AI safety. And so I decided to leave my job at a startup called Ripple Match, where I was head of AI, and then spent a long time thinking about, with my co-founders, like what we wanted to do, and then ultimately decided that we felt that interpretability was like the single most important problem in the world to be working on. Um, and at least for myself, like what I know how to do is build startups, build companies. Like this is, what I've been doing my entire career. And so we just came to really deeply believe that there is an opportunity in interpretability in order to build something really durable and impactful. And since then, and then we met Tom, our chief scientist, third co-founder at Goodfire, who started the interpretability team at Google DeepMind back in the day. And yeah, it was a great match, and we just like all were thinking very much in the same way. This is the most important problem in the world, and how do we sort of build the flywheel engine that can really scale this fundamental research into how neural networks work and how they learn.
Sorry, let me just yeah, sorry, keep going.
Yeah, and yeah, so since then, we've scaled the company quite a bit. We're about 50 people now. We recently announced our Series B at a $1.25 billion valuation. We're always looking for great folks to join the team, so I encourage everyone here to check out our careers page afterwards. And yeah, excited to tell you more about what we're doing and answer all your questions.
Yeah, let me just like post the link here too as well. They're hiring for a wide variety of roles. So not just limited to machine learning engineers, also people with like more bio backgrounds, business, go-to-market strategy, product people as well. Maybe you want to share, I think the questions are still kind of like coming in. And let me
Yeah,
just
I have some slides to share.
Oh yeah, go
Cool.
for
So
it.
just chat through a little bit about what we're working on. Can everyone see these okay?
Yeah, we can.
Okay. So, as I said, Goodfire is a AI interpretability research company. There's not a lot of companies that are focused really, really deeply on interpretability and not that much else. Of course, there's great work at some of the labs, but like we, breathe, eat, sleep interpretability. It's central to everything that we do as a company. We are backed by $209 million for some great investors, and we were Anthropic's first ever corporate investment. And our team is some of the best interpretability researchers in the world from places like DeepMind and OpenAI, Stanford, Harvard University. And we work with many great partners across the industry. So Mayo Clinic, Microsoft, Arc Institute, NVIDIA, Radical AI, some startups as well, especially in the scientific discovery space. Um, Great. Okay. So The first thing that I kind of want to say about what we do, like what is our mission as a company? We believe that interpretability is the foundational science that turns AI into something that we can intentionally design. And what we mean by that is that we envision a future where building AI can be more like building software. With software, you can audit the code, you can understand when there's bugs, you can look and fix them, you can deploy those fixes quickly. You can have a sense of how the entire system works together. And we believe fundamentally neural networks are programs. Um, Gradient descent is just a way to learn a program, and those programs have logic and structure inside of them. And understanding that logic and structure unlocks a lot of great things. But ultimately, our vision is we're building more and more towards super intelligent systems. I want to be in a future where human beings are, in the passenger seat, let alone the driver's seat. And I think the only way we can possibly get there is if we can start reverse engineering these programs. So maybe if you think of a model as a compiled program, you can think of interpretability as a decompiler, which gives us a sense of how that program is actually working under the hood, so we can audit it and put it back together better than we found it. Um, and one thing I always want to point out to people is that this is pretty much unprecedented in the history of science, that sort of engineering has outpaced fundamental understanding in the way that it has for these large models. You know, um, Although things have moved forward a lot, people still don't fundamentally understand how they work or what's inside of them. Um, you know, uh, Maybe a good historical precedent. It was the folks at Timaeus who originally used this, so this isn't our own, but steam engines pre thermodynamics, right? Like we figured out how steam engines worked, and then we figured out the underlying science, and then that helped us build better and better engines over time. We think that machine learning is sort of pre thermodynamics, and one of our missions as a company is to figure out that fundamental science that lets us intentionally create AI systems. Um, and one other thing I want to call out as I talk through our work a little bit is that we believe interpretability also serves as the bridge that allows us to learn new knowledge from super intelligent models. So I'll give you a quick example here. Um, Tom, our chief scientist, and his collaborators at DeepMind, they looked in superhuman chess models to understand what those models actually learned. And in the process of doing that, they were actually able to teach new techniques to human chess grandmasters. And this is just one small example, but we call this AI to human knowledge transfer, where we have superhuman AI systems. By reverse engineering how they work, we can actually generate new knowledge from humanity. And I think science isn't just about prediction. Science is about understanding. And so how do we have human beings play a role in the future of science? I think the only way that we can really do it is by deeply understanding how these AI systems work under the hood. So I'm going to give you all three verbs as I talk through some of the work that we've done. These are the three verbs that we think about in everything that we do. So understand, debug, and intentionally design. These are the things that interpretability can unlock. So I'll start with understanding. So our team does a lot of fundamental research. This is a personal highlight that I really like from some members of the team as well as external collaborators. We developed a new type of sparse dictionary architecture specifically oriented around the question of how in-context learning can update beliefs in a model over time. So one of the problems with sparse autoencoders, which maybe some of you are familiar with, is that they assume that a model's representations are static. But we actually know this isn't true. And this is even more relevant with reasoning models and agentic models. In order to really understand what's happening, you can't just take a snapshot of them. You have to understand how they evolve as dynamic systems over time as they're pursuing their objective. And so this was a pretty cool work that demonstrated that we could actually develop sparse dictionary learning methods, which were able to understand these models as more of a dynamical system. Another example of understanding is we've done some great work with Arc Institute, looking at their Evo2 model, which is now in Nature. And we helped contribute to this mechanistic interpretability figure that you see here, which is actually about what has Evo2 learned. Again, actually, let me take a step back. So Evo2 is a genomics foundation model. What that means is that it is a autoregressive model, kind of similar to an LLM, but trained on the genomes of every reference genome that's available. So everything from bacteria to animals, um, plants, and in the process of doing that, uh, the model actually learns a little bit about evolution. It learns to model evolution in various ways. And so this work is a little over a year old now. And this was just our first glimpse inside of Evo 2. But we've now studied this model very, very extensively. And the pattern has consistently been with these genomics models, they actually do learn really deep things about the biological world, much deeper than I think many people naively expected. And yeah, I recommend checking this out as a primer, but we'll have some forthcoming work relatively soon too, which further expands on the everything that's going inside of these genomics models, which seem to have really learned quite meaningful things about the biological world. And here's another example of that. So we did some work where we took a look again at Evo 2, this genomics foundation model, and we asked the question, how does Evo 2 model the differences between organisms? So for human beings, when we talk about evolution, we have a ontology, so phylogenetic trees, which are very useful for us. And we wanted to ask the question, does Evo 2 understand phylogenetic trees? Does it understand the relationships between organisms in the way that we do, which is this sort of tree-like structure? And you can see this sort of tree-like structure on the bottom is a projection of the underlying much higher dimensional manifold that Evo is using to represent phylogeny. But we did in fact find that the model had learned this sort of fundamental relationship between organisms in a way that we were able to reverse engineer out of the model. And our goal with all these biological foundation models is ultimately to bridge the gap of in silico science towards biological groundedness so that we can accelerate the processes of things like discovering biomarkers and drug discovery and all these exciting things people are applying AI for. But right now, our view is that um, the industry is throwing darts while blindfolded. And instead, by actually understanding how these models are working, we can bridge the gap towards superhuman prediction in order to really accelerate the scientific progress and actual understanding, both of these models and the fundamental biological systems that they represent. And one example of us doing this pretty recently was with a partner called Prima Mensa, where we looked at their epigenetic foundation model and we were able to find a surprising signal inside of that model, which had not been previously explored for Alzheimer's disease. Turned out when we distilled this information from the epigenetic foundation model into a proxy model, we were able to recapitulate a lot of the performance of the original model. So this is an example of how we can take a foundation model. It's performing a task very well. Nobody knows how it's doing it. We can reverse engineer it, and then we can take those insights that we've learned from the model and use them for other scientific purposes. And this is just another example of sort of what we found inside of the Pleiades model. Again, the specific biomarker class that we identified here was fragment length, which, fragment length did have a history in other diseases, but not specifically for Alzheimer's. And so it was a surprise to learn that the model was depending on fragment length signal as much as it was in making its prediction. Cool. Now I'm going to talk a little bit about debugging. So we think of understanding as the first step, and then debugging as the second step. So models can contain very rich information. Sometimes they can do incredible things and nobody knows how. Sometimes they don't work the way that we want them to work. And can we actually isolate the mechanisms responsible for that? So here's an example of work that we did in terms of understanding how memorization works in models. So by factorizing the weights of the model in a very specific, theoretically motivated way, we're actually able to identify weights that are associated with memorization of specific sequences. So this is relevant for, say, like copyrighted material, benchmarks, benchmark gaming, things of that sort. By pruning those weights, we can actually reduce memorization with very minimal regression, and sometimes maybe in some cases even slight improvement on certain logical benchmarks by giving the model a little extra capacity. we've also identified examples where reasoning models are not reflecting their actual computation quite as directly as you would hope. So you can look at the chain of thought to get a sense of, sometimes at least, what is the model doing? How is it sort of thinking about the process? But it actually turns out sometimes that the model knows the answer and just thinks for a really long time anyway. And so the way that we approached this experiment was by, you know, um, we had a few different techniques that we used, but like one simple one was just literally force ending the chain of thought and seeing how that affects the resulting answer. And it turns out that if you do this, yeah, sometimes the model is genuinely reasoning, and but a lot of the time, especially on simple problems, it's not. It already knows the answer. You're just wasting a bunch of tokens, and it's not reflecting its underlying computation. We have some more work that should be coming out soon on sort of chain chain of thought faithfulness and things of this sort. But I think it's a really interesting problem area for models, and interpretability is one of the things that can give us insight into how to fix some of these problems. And then the final thing that I want to talk about is intentional design. So intentional design is when we take the insights that we've learned from debugging models and we use these to improve models in various ways. So a good example here is this feature as rewards work that we did, where we were able to identify, turns out that models actually know when they're hallucinating, at least a lot of the time. And we're able to use interpretability in order to detect when a model is hallucinating. And then we were able to use this information, can go into more details in the setup, but we were able to use this information in order to train a model to correct itself. So when basically teach this model this underlying behavior, which it didn't have before, of wait a second, I'm hallucinating. I should double check my work. Um, and this is just an example of the types of things we can do with intentional design. Ultimately, we were able to lead to a huge drop in hallucinations as a result of this work. I believe as large as a drop as GPT 4.0 to GPT 5 drop in hallucinations through using this technique. And one more example of intentional design is this is a work that we just put out like a week ago. So we're very interested in accelerating scientific discovery. I think this is a thing that matters a ton to us as a company. And we were able to, in the material space, turns out that let me give a little bit of context. Um, the goal of the sort of AI for material discovery space is what if we can find specific materials that have the properties that we want them to have in advance and therefore save a bunch of time in what is currently this very manual process of trying to figure out how to manufacture materials with certain properties. Of course, the very eye-catching example is like, well, what if you could build, a room temperature superconductor or something like that? But I think there's many, many examples of how like even small improvements in material manufacturing processes can lead to huge reductions in the cost of goods and improvements in underlying technology. Maybe batteries are like another good example, semiconductors. And in this case, we actually looked at semiconductors, properties that are relevant for semiconductor materials specifically. And what we showed was that these material generation models, they actually have a deeper understanding of these underlying physical properties than one might naively guess. And by using those representations as guidance during the diffusion process, we can actually correct the search process such that we develop materials that fall within a very narrow range of some properties, which is what's necessary for semiconductors. And you can see here there's a pretty large improvement over or baseline methods. Won't go into all the technical details of the materials work here, but I think this is another interesting example. Um, yeah, so that's all the slides that I had. I guess one thing I would just want to highlight is that this is just like a sampling of our work. We have a ton of unpublished work. The next like couple of months are going to be pretty crazy in terms of things that we have coming out, and I'm excited to share with everyone. Um, but and we've also only been around for less than 2 years, so we've been working hard and making a lot of progress along the way. And we're always looking for great folks to join our team. We're really scaling up, especially on the product and go-to-market side of the organization as well as the research side. So awesome.
Very nice. Thanks so much for sharing the slides, Dan. That was like a really good like overview of like the work that you're doing, and people were all like very impressed. Um, and maybe I'll just like punt over some questions that people have been raising in Slido and just like to start asking you here. From Sebastian, what do you think about the pragmatic interp stance that DeepMind has taken?
Yeah, I think broadly, I would agree with pragmatism being pretty central to the work that we do. I think we have a different research agenda than DeepMind, and we approach the problems and the partnerships that we work with in a slightly different way. But I fundamentally think that we should have a wide tent view of interpretability. I think there are techniques that I would count as interpretability techniques, which don't necessarily use model internals. There are techniques that use model internals. Maybe the best technique is a probe for many things. Probes are really good, especially when you know what you're looking for. Sometimes you want unsupervised techniques when you don't know what you're looking for. I think there's a wide suite of tools that all should fall under the tent of interpretability. Fundamentally, interpretability is not about pushing forward specific techniques. It's the science of how we can understand models better and better. And I think, like ultimately, you should just use whatever the best tool for the job is for whatever you're doing.
Nice. Thank you. And I think some people were really curious, like why Neil Nanda said that it was a bad idea to start a mech interp company.
I actually think it was like a pretty reasonable statement. His I mean I think there were two things. Like I think early on we faced a lot of skepticism from like, hey, is there actually a market for interpretability? I think now we feel like very confident that there is in a bunch of different ways. But I think that was reasonable skepticism to have at the time because nobody had proven it out. Like we are sort of uh, we are a market making company, which is fundamentally a really hard thing to do. And then also, Neil pointed out that the base rate of companies succeeding is extremely low. So I think from his perspective, it was all reasonable. I think I'm just we all as on the founding team and are very, very headstrong, and also we are pretty experienced and have done this before, and so I think that makes things a lot easier than otherwise. The comment wasn't specifically directed at me; it was directed at a larger audience, and honestly, I think it was probably pretty good advice, all things considered.
I think a few people also had like other questions about like the like business model of like of Goodfire. For example, like who are the actual customers that you have and what is it, the specific thing that you're selling to them?
Yeah, so we work with a lot of partners across a lot of different industries. Our fastest growing vertical is life sciences, and we work with a number of life science partners. Mentioned a couple, say Mayo Clinic, Arc Institute, as examples. Generally, like what we do with customers is those three actions that I described earlier. We understand their models, we debug their models, and we help them intentionally design models. The way that this works is that we have a underlying platform, which we'll be talking about more publicly relatively soon, which allows for the deployment of these interpretability tools at really massive scale in order to really understand what models are doing inside and then extracting that out. We also have forward deployed teams, forward deployed engineers, and forward deployed scientists who work very closely with our partners on the utilizing our platform in order to like drive all of these research results that we're seeing. So in the slides I showed you, probably about two-thirds of them are coming from relationships that we have with partners. And I think that's something that's really cool about all the partnerships that we're taking on is that we're taking on some of the like the most interesting and challenging problems in AI in the work that we're doing with partners. Um, so I feel very, very grateful for our partners and some of the really cool work that we're doing. And yeah, again, more to share there soon.
Okay, awesome. I think some people were really interested in getting into the nitty-gritties as well, especially with like your like one question is about like whether Goodfire has a public-facing detailed research agenda. Um, yeah.
Yeah, we have some stuff that's public facing. We'll have more stuff that's public facing. I think like probably so Tom, chief scientist, wrote a great doc on intentional design and why we think intentional design is really essential towards the future that we want to build towards. and highlighting some of the high level research goals of intentional design. We'll be sharing more things publicly over time. We're still a very small company, you know, like we've only been around for 2 years. We've spent at least a year of that trying to figure out who we were and what we were doing. But in general, like we're pretty open and definitely a lot more information will be coming out about both research that we've done and research that we intend to do.
Nice. Another like fairly specific question is like how much is Goodfire prioritizing feature discovery methods like SDL methods versus circuit decomposition methods like the SPD work that one of your colleagues, Lucius, works on?
Yeah, well, so I think the SPD project is really exciting to me. And I should have put that in the slides actually, but I think that's one of the most ambitious, interesting pieces of mechanistic interpretability research that we're doing. And for folks who don't know what that is rather than thinking about decomposing neurons, what if we actually just decompose the weights of the neural network into these like fundamental components of the algorithm? And so a lot of progress has been made on those, and I'm very excited about them. I also think like decomposing activation space, geometry of activation space type questions are extremely well motivated too. Again, to come back to my response to the pragmatic interpretability question earlier, I think of interpretability as a wide suite of tools. I don't think that there's sort of like one technique to solve interpretability. Instead, I think there's a bunch of different tools which each give us specific types of information that we might care about from a model. And we're interested in pushing forward high leverage research, which just like deepens our understanding of models along any of those important axes.
Nice. Um, Other questions that people have on more like tactical things, I guess, with whether you guys plan to open an office in Europe.
Well, we actually do have a we have an office in London. We don't have an office in continental Europe right now, and currently no plans of doing that. But certainly a possibility maybe at some point in the future.
Nice. And they're also people are also wondering if Goodfire is planning to run another iteration of your inter-fellowship program.
Yes, we are actively generally like recruiting fellows. For all types of projects. So if that is something that somebody is particularly interested in, if that is not on our website right now, then it should be back up on our website. We're always sort of looking for fellows to join.
Perfect. I'll put a link in the chat as well if I can pull it up later. Um, on the a broader question about AI safety or the needs of orgs, AJ Weeks is asking, do you believe more in for-profit or not-for-profit AI safety orgs in general, or are both viable and needed?
I think both are valuable and needed. Yeah. I think it just really depends on what problems you're trying to solve. And I would just go so far to say is like, I think again, I think a wide tent is good. Like, I think taking lots of different approaches to the problem is good. Pushing forward like empirical science, both of, you know, what safety solutions can actually matter, and then also like what are the sort of like strategies in order to deploy safety more widely. I think it's super important. I think for us, like we wanted to start a company in interpretability because we believe there was an opportunity to create a flywheel where there was a market and the needs of the market would mean that we had to understand models more and more deeply. You know, we don't want interpretability to sort of be we want interpretability to have the amount of compute available to it that training foundation models has, maybe as like one easy way to say it. And the way that we get there is that we fundamentally prove out the market that we're building, that actually understanding models is something that is highly valued. That being said, I think there's many examples of nonprofits that are doing great work, you know, in evals and underwriting and all types of other aspects of AI safety. There's also great nonprofits that are doing great work in interpretability too. So I think it's sort of a big tent, and there's many different approaches that make sense for different orgs, and that we should all just be trying to do everything we can.
Fair. Some people are really excited about the roles that you have and are asking like, if you could describe a bit more of like what's the shape of talent that you're looking for, and what sorts of backgrounds would you find like most useful for the kind of research that you're doing?
Yeah. So we're hiring for a lot of different roles, so it's hard for me to give like a really concise answer to this. We're looking for very highly mission-driven folks. Um, definitely, definitely right now, like rapidly growing on the product engineering side of the org, building out like like our product is really all about translating these fundamental techniques in understanding how models work into the types of form factors that we can really scale and serve to a larger and a growing number of customers. So we're very actively hiring there. We're very actively hiring on the go-to-market side of the org too, on like the business-facing side of the org. Um, on the research side of the org, both like fundamental and applied research, we're looking for great researchers, great engineers, like always. And I think for us, fundamentally, like maybe some cultural things that are just helpful to understand is like we're a very fast-paced culture. Like we believe in like, um, moving quickly, iterating really quickly, uh, you know, sharing progress of work frequently. Um, Very pragmatic, focused on like finding the thing that works, and finding the thing that works as quickly as possible. We're very focused on real world use cases and building, like with the market. And we also like, just to be clear, like we believe we're taking a number of like big fundamental research bets too, which are going to take many, many months, maybe even years to fully pan out. But I think for a lot of folks who are now moving into AI safety, say from who have previously worked in startups or previously, worked in big companies of some kind, also biotech, since we do a lot of work in life sciences, I think that those would be candidates that I'd be really excited to talk to.
Nice. Are there any like particular examples of like surprising hires or like people who I feel like sometimes when applying for roles, people often self-select themselves out because they feel they don't fit a particular description. Is there like an example that comes to mind of a person who you were really excited about but didn't fit like a traditional description? Maybe it's too specific of a question, but
Yeah, I mean, I think several. I don't want to put I don't want to put anyone on
yeah,
Goodfire,
yeah, yeah.
on blast publicly. But I
That's
think,
true.
at the highest level, I think if you're interested, like you should apply. We do have a general interest bucket too, and so if you don't know where you fit in the company, I would just apply to general interest, and then we can talk from there. I think a lot of people have been like very successful at this company, coming from a wide variety of backgrounds. And I think it's that diversity of perspectives which is necessary to build like a really successful company with a really high impact.
Cool. A few people had more questions about like the theory of change for Goodfire as it relates to like helping make AI go well with AI safety. Um, uh, I guess the question is like, how does trying to understand the model internals then help to make AI systems safer?
Yeah, I think at the highest level, like we can take the strong version of the like interpretability argument, and then I think like I can sort of kind of walk it back a little bit to help understand how we think about it. But the strongest version of this is like, again, AI models are just programs, right? Like they're enormously complicated programs, but they're programs at the end of the day. I train a model to do modular arithmetic, it learns a program. We can reverse engineer that program. That's a very simple program. Language models, frontier language models today, they're very complicated programs. But it turns out when we look inside of them, we can understand a lot of what's going on there. I think I think that there's like two doors for humanity that we can choose, we can walk through right now. There's one door where we build a super intelligence that we have no idea how it works. And then there's one door where we build a super intelligence where we understand how it works at least a little bit, And I think we want to push that fundamental understanding as far as we can possibly push it because interpretability allows us to do things that no other form of safety research does, And I think oftentimes other forms of safety research are quite complementary, right? Like if I understand how a model works, I can red team it better. If I understand how a model works under the hood, I can evaluate it for things that are harder to evaluate in a pure black box method. Eval awareness being like a good example of this type of thing. I think there's just like many such examples, and like the main thing I would just say is like every inch of fundamental understanding that we can push forward, like translates into tons of practical new techniques that wouldn't be accessible otherwise.
Nice. Thank you for answering that. Um, hmm. I guess like Sean has his hand raised. Maybe I will, yeah, let you unmute and respond.
Hi. Uh, Apologies for not writing this in the chat. As you can see, I'm in the car, so I'm trying to multitask here. Hi, Dan. Thanks for having us today. I'm Sean. I actually just finished the Blue Dot course. I'm a software engineer by trade, looking to pivot into research engineering for interpretability specifically. I was actually really drawn to the research agenda memo relating to like intent-based interpretability and using that to sort of intentionally steer models in a way that's like aligned with human intent. And so that naturally led towards gravitated me towards the RLFR paper. I've been working on like my own sort of open source implementation of that, trying to generalize, see if this particular technique could generalize to other open-ended like QA type problems. Right, you guys found it like systematically reduced hallucination. I'm curious, can this like apply to other particular domains? But the deeper I dig into the paper, the more I find that it's actually like quite bespoke. Like the data collection pipeline you guys have is like there's multiple LLMs as a judge in the middle in order to like generate the answers, and there's actually like 4 different probes that we're using, and so that got me thinking. Do you guys have plans to like open source any of the code for these papers? I'm just curious. A few questions, but that's my first one.
Yeah. Well, I guess first I'll say, yes. In this particular case, there were a lot of steps involved in the process, and that's actually, I think, largely downstream of the fact that like figuring out how to detect hallucinations well inside of a model was really challenging. So a lot of the work was actually in building the probe. And then once you have the probe, I think things are a lot simpler and more easy to transfer. So focusing on things that are easier to probe for a replication. There are many things which are quite simple to probe for. Might be a good place to start. In general, we do open source a lot of the research that we do. In this particular case, I actually don't know. This wasn't my team that was responsible for the research, so I'm not sure if we'll open source it or not. My guess is that we probably won't open source this particular one, but if you're interested in like replication, I can feel free to reach out and can
Yeah,
give you
that would
some
be
points.
great because I'm like I said, I'm working on such a replication and looking for ways to possibly streamline that initial process of gleaning or training the probes. So thank you. I may reach out to chat about that further. But last question for now. I work on a FFRDC space. It's federally funded R&D centers. Through that, initially, specifically, I work for the MITRE ATT&CK team. I don't know if you've heard of the CVE, the Common Vulnerabilities Exposures. It's basically like the sort of global database for all well-known exploits. So like naturally, that gives me a particular interest or angle in the cybersecurity space. You mentioned that you guys are working to sort of partner more in like the life sciences. I'm just curious if you guys are also trying to break more into the cybersecurity space. I really liked what you said earlier about like using interpretability or ASI to glean or yield new knowledge, and then extracting that knowledge from the model. I've been equally curious about, just as an example, employing ASI agents into some kind of evaluation sandbox where we can run them against like a Monte Carlo type thing, uh, have them identify new zero-day exploits, and then look inside the models to see if we can glean some kind of like generalizable behavior that we could then cook into something like the CVE or the MITRE ATT&CK framework. And I'm just curious if cybersecurity is like an angle you guys are looking at.
Yeah, so I think there definitely are applications of interp in cybersecurity. Number of things that I'm aware of, some that have been done by us and some that have been done by others. Um, Yeah, I think it's definitely a very interesting space. We are a startup of 50 people right now, so we are growing pretty quickly and interested in tackling new and important problems in the world. I think clearly right now is a very important time to be researching and understanding deeply the cybersecurity impacts of the models that we're developing. Um, yeah, so not a huge area of us so far, but I think it's very well motivated.
Well, thank you, Sean, for asking these questions as well. I'm going to bring it back to the Slido. Some other questions have emerged. One from Philip Anthony. A large challenge for a research-heavy company can be to translate technical research both towards customers and the public. Um, do you have people on the team like tackling specifically this?
Yes, yeah, we do. Yeah.
Yes.
Yeah, I think yeah, so I think there's a few different aspects of this. So I think like the work that we do and how we communicate it like can come from a few different angles. So again, we have a pretty big forward deployed team, and our forward deployed team like works really closely with our external partners in order to help get them understanding and utilizing our techniques effectively, and also sometimes even developing brand new techniques. So there's going to be some examples in upcoming work that we're putting out soon of brand new interpretability techniques, which we first developed on biological foundation models, um, but can also have impacts in other modalities as well. Um, but then also like we do a lot of fundamental research and like translating that into a way that's like understandable and consumable by the public is something we spend a bunch of effort doing. As I said earlier, like we have a lot going on internally that we have not shared, and that's not because we're like secretive, but it's because the process of like putting stuff together and getting out in the world is actually very time consuming and very difficult. So I think it's a really, really important function.
Yeah. Writing is hard. Communicating like very complex ideas in a very simple way is a tough task. A question from Will Maynard. How much do you collaborate with Anthropic and DeepMind's interp teams, and what does that collaboration look like?
Yeah, in a research capacity, we've collaborated with both teams a decent amount. Yeah, I think there's like good relationships with those teams. We don't have any formal arrangements with anything, but I think like in thinking about high impact interpretability organizations, there's a few industry and there's a number of academic labs as well. And yeah, we partner with all of them on lots of different projects uh, for all different types of things. Um, so yeah, not really a formal relationship, but like lots of research collaboration.
Um, from somebody else, there's a school of thought in AI safety which believes that interpretability is a dead end and that we don't need a nuts and bolts understanding of models to make them safe. What's your point of view? Well, I mean, you've already stated your point of view like multiple times, but
Yeah, I mean, I can state it again and address this question directly. Um, I don't know. I mean, there's like strong claims I like wouldn't necessarily make. Like, do I believe that interpretability is the only way you could align a model? Like, not necessarily. Do I believe that? Um, do I even believe that like we are going to be able to fully reverse engineer what models are doing? Like, not necessarily. Like, but I would bet two things. I would bet that we can reverse engineer them enough that it makes aligning a model a whole lot easier, and like pragmatically, that is the thing that I actually care about making happen and building this company to do. So yeah, I mean, again, and I think like people should explore all different types of angles. I would just like put forward, I would postulate that well-developed interpretability techniques, and we're still in many ways in the early days of interpretability. It's matured a lot, and I think just looking at the rate of progress over the past few years should put a lot of the naysayers' doubts at least somewhat to rest. But it just seems like way easier to debug, figure out what's going on, do empirical research if you can actually understand what the thing that you're looking at is doing under the hood. And yeah, I think my goal is, I'm not saying that this is the only thing worth working on, period, but I think it's the only thing I want to work on because I think the likelihood that this radically improves the probability of things going well is very high.
a follow-up question is that from somebody in the chat is the focus more on trying to make the system safer or more about trying to get the most benefits from the models?
Well, I think these things are like really deeply related in a lot of ways. So I don't think it's quite a dichotomy.
Mm,
Like there are many things that like you can point at that are both like failures of debugging models effectively that get in the way of their usage, but also are alignment failures. Like I think sycophancy is a great example, and so some projects that we've worked on are seeing ways in which we can intentionally design models such that even when sycophancy is a property of the data set, they don't learn to be more sycophantic. Um, I think ultimately, like we exist as a company because we believe that there is a really big market for fundamental understanding of models, and increasing fundamental understanding helps all of these different things that we care about a lot. So I don't really think of it as like a binary between risk minimization and upside maximization. I think like they're both pretty central to what we do.
yeah. This is also probably part of the reason why Goodfire is a public benefit corporation and not like a fully for profit. Maybe you want to say a bit more about that, like decision.
Yeah, I think at the highest level, I don't think that AI is a normal technology. I think this is the most important and transformative technology in human history, besides maybe fire. Uh, um, and actually that is where the name comes from, so I'd be happy to do an
Oh,
aside on that in a second. But
okay.
first to answer the question, yeah, basically, what a public benefit corporation allows us to do is it allows us to make choices if we need to, which are not just about profit maximization. I think our goal as a company was always like companies are optimization engines. And so our goal as a company was always to find the right market such that we like deeply believed that the arrows between what we fundamentally want to accomplish in the world and scaling in the market are like really, really deeply aligned. And I think we've accomplished that. But nonetheless, like this isn't a normal technology. Things are going to get pretty weird. We might have to make some pretty weird choices. And being a public benefit corporation just reserves us some rights that wouldn't otherwise be available in those situations. Um, and maybe just quickly on the name Goodfire.
Yes, yeah.
The name Goodfire comes from like fire is the fundamental technology. So of course, like fire was the first technology, and fire has powered everything. It's allowed us to cook food, therefore develop agriculture, therefore smolt metals, build steam engines and power the modern industrial era. And so fire has a immense constructive capacity, but it also has an immense destructive capacity. It can get out of hand, it can spread wildly, it can cause problems, destroy livelihoods and lives. And so yeah, I mean, like, so we just think AI is like very analogous to fire. So taking the idea, the analogy, which wasn't ours, that it's the most transformative technology since fire, but just literally saying good. We'd like this to be the good type of fire and not the bad type of fire.
It's a good story. It's always nice to have just like the same name of your company just reminding you of like the thing that you're trying to achieve. Cool.
Yes.
A slightly broader question as we like bring this conversation slowly to a close. Like, what are the key challenges that Goodfire is facing for the coming, maybe for the coming year?
Yeah. So I think, as I said, like while we've learned a lot about how neural networks work, we've made a lot of progress as a field and as a company. There is still a lot of work to be done in terms of fundamentally understanding not only how these systems work as artifacts once they're trained, but how they learn in the first place. Um, I think particularly I think it's very clear that a lot of people are working on continual learning in various ways. If you think about our work with, sort of sparse dictionary learning methods that can understand the dynamics of models, even in context. We're going to have to understand the dynamics of models as they're trained. Um, and it's going to change the safety surface enormously once that type of technology starts getting deployed. Because you no longer just have these like static assets. Instead, you have a system that is learning and evolving over time. And so understanding the fundamental like research of how neural networks learn in the first place and how we can shape that learning process in ways such that they don't become more misaligned over time is a pretty critical challenge that we're really interested in doing what we can to help address. And then On the business side of the organization, I mean, we're scaling really quickly, we're growing really, really fast. I think like many, fortunately have done this before, so I know many of the challenges that come with scaling a startup. But nonetheless, scaling a startup comes with many challenges. You want to grow, the number of partnerships you're working in as quick as you can, but you don't want to dilute culture at all. You want to make sure that you're hiring the best people in the world across all of these different types of roles. And it's a very exciting time for a company, but making sure that we scale and we scale really effectively is also really critical.
Yeah. Um, Yeah, and just a reminder of like Goodfire's like open roles, and also like if you would like to start taking action, like learning about AI safety, learning about the landscape of techniques, you can also try out like Blue Dot's like courses that try to help you more with this. And as we try to like come to a close on this conversation, I'm curious like um if there is anything that you would like to say to this audience of like people who are aspiring to work in AI safety? Maybe like advice you might have given to a younger version of yourself back like
Mm.
2 years ago, that might help the people in this room kind of like figure out and orient themselves to figure out like how they can take action as well.
Yeah, I think that's a great prompt. I would say the biggest thing is like there are ways for the folks in this room to contribute. There's a lot of different ways that um, one could be making an impact in AI safety. There's many different routes. There's for-profits, there's nonprofits, there's technical work, there's policy work. Um, and I would just encourage everyone to like, of course, like understand the space, learn what people are already doing, like, um, but also like think independently, think outside the box, think creatively, look for things that nobody is doing yet that could be really high leverage and important to be building. Um, as well, I think, more broadly, like figuring out how we transition safely and effectively into this AI future that's being built is the most important problem in the world. And I think there's many different perspectives and many different approaches to that would be really valuable and probably, thousands of great ideas that just like aren't even happening yet. So I would encourage everyone to bring their own perspective and their own background and try to come up with creative paths forward.
Yeah. And I think like everybody has a very like unique set of like skills and experiences that also give them a very different perspective on like how to solve this extremely complex problem. And we're really excited to see like what the people on this call decide to do or how they take action towards this. And yeah, well, I just want to say once again, thank you so much, Dan, for taking the time to chat with us, and for sharing all of this. And yeah, hope that more people will be applying for your roles as well.
Thank you so much for having me. Yeah, it was great to be here and great
Cool.
questions.
Thank you, everybody. Bye.